Hello, my name's John Pocknell, Toad for Oracle Product Manager, and welcome to this multi-part series on enabling agile database development using Toad for Oracle. In step 4, we're going to talk about how you can optimize your SQL and PL SQL code using Optimize Current SQL feature in Toad. So why is this important? It's a well-known fact that addressing SQL-related issues in development costs a fraction of what it would cost to fix in production. So in other words, the earlier we fix the problem, then the cheaper it is for the business. Poor SQL execution in development and tests can cause major problems in production, which are exacerbated by scalability issues. More transactions, more users, more data. And this can lead to expensive rework and associated business cost. Developers, often not sure what to do to fix a poorly executing SQL, will often rely on a DBA to fix the problem for them, and that can be extremely disruptive. So developers often try to rewrite the SQL manually, but this can be very time consuming and is often ineffective. So how hard can it be to rewrite SQL? Well, it might surprise you to know that for a moderate SQL statement, as you can see on the right hand side here, there are actually 30,491 possible ways that you can rewrite this query. Now granted, some of those rewrites will have the same execution plan, but if you look at the optimization details in the small print here, you can see that 985 of these rewrites generate a unique execution plan. Now that would take a developer hours and hours and hours to be able to do manually. And that's the purpose of SQL Optimizer. SQL Optimizer basically automates this rewriting operation and generates multiple rewrites in seconds. So let's take a look at this in a demo. So you recall in my previous video, we used the PL SQL profiler to identify a performance bottleneck. And by tuning the SQL statement, you can see the resulting effect there with the run on the left. So let's actually walk through the process of tuning that SQL statement. So here is the stored procedure that we had before. And when we used the profiler, we'd identified that it was the second SQL statement that was the one that was causing the problem. So what we need to do is tune the SQL statement. So we can tune this SQL statement actually in situ. We don't have to copy and paste it or reformat or anything like that. Toad will do that itself. So we come up to the toolbar here and we select Auto Optimize SQL at caret using rewrites. So again, no need to highlight anything, just as long as the caret is in the SQL statement somewhere, then that's fine. And what will happen is that it will automatically reform the SQL so that it will execute outside of the PL SQL program. So you can see it's removed the into and it's replaced the locally declared variable of depnam with a bind variable, depnam, so that when it executes, it will prompt for a value for depnam. So click OK. So we have some basic options that we can put in here. We can limit the optimization to a number of minutes if you've only got a short period of time to do this. If the SQL statements normally would take a long time to run, and that's why you're trying to improve performance, you might want to limit the optimization process to simply generate rewrites without actually executing anything, and then execute them after the rewriting process has happened. You can also refactor the SQL before optimizing, so making sure that you're taking advantage of any efficiencies that you can build into the way the SQL statement has been written. For example, converting decode to case statements, removing subqueries or changing subqueries into the right syntax ahead of time. So I'm just going to go ahead with all the defaults and have it generate the rewrites for me. So that's going to first of all prompt me for a value of depnam because it's now using a bind variable. I've got a value in here which I've entered, and I'll click OK, and that will initiate the process of rewriting. So now it's going to take that original SQL statement, as you can see displayed inside the window on the right here, and it's now looking for alternative rewrites. It will execute each of those to collect the execution statistics, and then when that's done, I'll be able to compare them side by side. So now you can see that it's generated a variety of different rewrites, in fact only 5 in this particular case. The optimization process actually generated 133 rewrites in general, but only 5 were tested because the remaining ones had the same execution plan, therefore there's no benefit. Something else to notice too is that you can alter the goal of the optimization process by elapsed time or CPU IO or any of these other metrics. It's found a better alternative, which is alternative number 1. If I click it, you can see it viewed here. But let's actually get a sense of how it compares against the original SQL statement I had in my store procedure. So that is the one on the left-hand side that was in the store procedure. On the right here is the rewritten one. You can see quite a few changes in the syntax. And then down here at the bottom, you can see the execution plan displayed. So you can see any differences in here, as well as execution statistics. So it's basically executed in significantly less time. The original SQL statement took 31 seconds. The best alternative ran in 0.27 seconds. So a big improvement. And so all we need to do at this point is to copy and paste this statement and put that into our store procedure. The other thing you could do if you wanted to explore other avenues such as indexing, you can launch a SQL Optimizer UI from inside of here. That's this button here, Advanced SQL Optimization using rewrites, indexing, and other methods. And so what the full SQL Optimizer UI will give you is the ability to try some other things like using indexes and some of the other advanced things like batch optimization. So if you've got a lot of SQL statements and you want to optimize all of them, you can put them into a batch process. Scan SQL, which is a way to identify problematic SQL in your source codes. This is more like a proactive approach to dealing with performance rather than waiting until you discover that there's an issue. And many other features. So that's a possibility too. So that concludes this session on SQL optimization. Thank you very much for listening.